introduction to Git for scientists. So the idea behind this is, well, maybe you're not familiar with version control or with Git in particular, and therefore we're going to start, like we do with most things on Lockdown Learning, kind of at the beginning, and introduce this more or less from the ground up. Okay, so why version control at all? Why is version control important? Particularly for code, but actually for lots of things besides. And this is one relatively eloquent example of a situation where version control might be a useful thing. So to people who have ever written any kind of collaborative document where that document gets emailed around and people send you revisions and so forth, this kind of situation will be fairly familiar to people, I suspect, where you've come across a final version of the document, and then that gets changed repeatedly until it's changed beyond recognition. And this is, although actually for Word documents, version control doesn't actually work terribly well, because they're binary, because they're not plain text. But this is the kind of situation, and it's not just for documents like Word documents, where you might want to consider version control. So this kind of ad hoc version control, based on the names of files, for instance, changing over time, doesn't scale very well at all. And also, what typically tends to happen is changes get lost or forgotten, or you end up keeping so many copies of your document because you want to keep a kind of the version history of your document, so you end up keeping lots and lots of copies, which is often problematic. And particularly for things like Word documents, increasingly these cloud-based services for document control, like Dropbox, Google Drive, Microsoft OneDrive, and various others, really can improve matters. You can share a document among many people, and people can make changes to that document. And the service that you're using tends to keep some sort of revision history, so that you don't necessarily have to. But the problem with that is that if you're sharing your document with other people, you risk deletion and corruption, and I've seen these things occur with documents in these systems all the time, because what happens on one computer propagates to the whole of the project. So if one person decides to delete a document, it gets deleted on everybody's computer. That's the way that Dropbox works, certainly. And this can be problematic. Although there's some kind of history for these documents, it's not always comprehensive. And if two people are editing a document at the same time as well, these systems can really get their nicks in a twist. And it's not great for projects which are maybe very deep in terms of the numbers of files and directories and things that are required. Sharing those big structures between lots of people can be very problematic. Fortunately, these are all problems which software engineers in particular, people who write code, have faced for a long time. Code writing is often a collaborative endeavour. You want people to be able to make changes to the same document simultaneously, and for conflicts between those changes to be resolved swiftly and easily. And so version control systems written for code control have existed for a long time and address an awful lot of these problems. And this is where Git comes in. Okay, so Git is a version control system, and specifically Git is a distributed version control system. And I will come back to that later and talk a little bit about what that distribution of it as a system means. So Git is capable of storing the history of all changes made within a project. You can use Git to roll back these changes at any time and at any point, and it's also useful as a tool for collaboration between users. So many users all using Git with the same project can collaborate effectively on a set of files, and Git can handle integrating changes from those multiple users. So Git initially was written by a guy called Linus Torvalds. Linus Torvalds is also the chap who wrote the original Linux kernel back in the early 90s. So this is a software developer, a computer scientist with considerable pedigree. He wrote it to manage the code for the Linux kernel, which has, because it's such a large and distributed open source project, has thousands of collaborators and an enormous code base. So if Git is a version control system that can manage that kind of software project, then it's appropriate for an awful lot of different types of project. Okay, so I'm not necessarily here to give you the propaganda and to try and sell Git to you, but I think nevertheless, if my spiel doesn't convince you, then so be it. So, but Git allows you to keep snapshots of your project, so you can freeze a version of your project at any point. So, for instance, at the submission of a publication, you could freeze a version of your project. You can then make changes, keep a track of that frozen version, but make changes and take future snapshots as well. So perhaps after revisions for a resubmission of a paper. Yes, entirely possible to kind of make those kind of changes. And keep track of important changes to code and other files, even allowing distant collaborators to keep up with developments, and also helps you keep projects organized and available, for instance, within a group after people leave. So in the bioinformatics support unit, we have a team GitHub account which people submit their code to, in theory, and then even after people have left the unit, we have their versioned code available to us to use in the future. GitHub also performs, as kind of by a side effect, relatively useful offsite backup for code and sometimes data, certainly small amounts of data anyway. So it's a useful set or a piece of software, and the ecosystem around it is also extremely useful. Okay, so on to some of the practicalities. So how to use Git. So first of all, installing. Right? So we like to go from the beginning here on Lockdown Learning. So if we assume that you don't have Git installed at all, which actually even on a newly installed Linux system, you won't have Git installed, as far as I know. And it's part of the base installation of Ubuntu, for instance, which we've used on Lockdown Learning a lot. If you go to the Git website, the recommendation for macOS, for instance, is to use Homebrew, which is a package management system which we haven't really talked about in any detail here. But it is extremely useful for installing command line software on Macs. And the Homebrew distribution of Git is simple to install once you've installed Homebrew itself. Homebrew is a little bit like Conda, which we have used here. I meant to look and I forgot actually whether there's a Conda package for Git. I kind of going to assume that there is. Yes, there is. There is indeed a Conda package as well for Git. So for us and the way that we've gotten used to working around here, you could quite happily install Git with Conda. On your Linux VM, on your Ubuntu machine, you could install using apt, so the built-in package manager on your Linux machine. And here is a little bit of a clue that these slides are a couple of years old. I'm a lot less hostile towards Windows these days than I used to be. On Windows, there's a package installer that you can use to install Git on Windows. The command line tools and command line integration in Windows is a lot better than it used to be. So yeah, there's an installer package for Windows available as well. Git is a little bit like some of the other tools that we've been using recently in our recent sessions. So SAM tools and BCF tools are the things that spring to mind, where you run them by running the executable along with a command. So SAM tools index, SAM tools view, BCF tools merge, things like that. And Git works in the same way. Git commands are in the form of Git verb, where verb is the thing that you want Git to do. Okay, so what the rest of this session really will go through a selection of these verbs. It is by no means comprehensive, and is intended as a guide to get you started as an individual user of Git. And I'm not necessarily going to go into a lot of the really detailed features of Git. Git's incredibly powerful and incredibly complicated, and I'm really just scratching the surface this afternoon. So the next bunch of slides is basically a selection of these verbs for the actions that you can take with Git. So this is our first verb, config. So Git config allows you to set global configurations for your installation of Git. So for instance, Git's a collaborative platform, so any commits, and we'll come to commit later on, but any kind of contributions that you make via Git are identified with your username and usually your email address as well. And so identifying yourself to Git is very important. So you can set your username, your email. You can also do other things with the configuration. So one important one is the core editor. So the bottom option here, setting your core editor to a text editor which you use and understand is very important. So here I'm setting, in this particular line, I'm setting my core editor to be Vim, which is a text editor which I've talked about on Lockdown Learning, but not really introduced in any detail because it's quite complicated to use. So for instance, if your experience of text editors is via Lockdown Learning, then you would want to set your core editor here to be Nano, so that when Git opened a text editor, it would open the correct editor for you, one that you understood how to use, so that you don't get stuck without knowing how to necessarily exit that text editor, which is often cited as a problem for Vim, for instance. So that's config, that's our first verb. And then init, so this is how you make a new repository or initialize a new repository. Git treats a directory and all of its subdirectories as a repository. So when you want to make a new directory, when you want to make a new repository, you need to have a directory which houses it. So in this example here, we're making a directory for our repository. Then we're changing directory into that new repository directory, and then we're running the command git init, which will initialize an empty Git repository in our current working directory. And so what this does in reality on your machine is it creates a hidden directory in your present working directory, this .git directory, and the presence of that .git directory is the thing which tells Git that this is a repository under the version control of Git. So the existence of that .git hidden directory is kind of that's the important thing as far as Git is concerned. If I show you just quickly, so this is on my, here we go, this is on my Mac. I'm in my, this is my Lockdown Learning GitHub repository. This is my local copy of it. So these are the files which have been uploaded to the Lockdown Learning GitHub over the last few weeks. And if I list this directory with the -A option, which tells ls to list all of the hidden files as well as all of the files you can normally see, you will see that in this directory there is a .git directory here. This .git directory is the thing that the existence of that tells Git that this is a directory which is under the version control of Git, and everything that's in that .git directory is, these are the files which Git creates and manages in order to manage this repository. So this is these files which you should never really go in and touch by hand. You should always let Git handle these files itself. But it's these files and the changes to these files which is what Git uses to manage your repository. That's the stuff which actually does the version control. So that's init for creating a new repository. So once you've installed Git on your local system, you can create a new directory which you want to keep under version control, and then within that directory you type git init, and then from that point onwards that directory is under the control of Git for versioning. Okay, so once you've got a repository, what do you do with it? So there's a couple of things. You can take a copy of other people's repositories. So this would not be into a local repository that you've just created. This would copy a repository onto your system from elsewhere. So clone is a Git verb which will take a copy of somebody else's code usually from a remote repository, often from somewhere like GitHub or GitLab, one of these collaborative websites which have been set up for sharing code. This is an example here of a git clone command where we're cloning from GitHub the Broad's copy of their G80K code, so the Genome Analysis Toolkit. So this is a reasonable example of cloning somebody else's GitHub repository. So once you've got a clone of somebody else's repo, you can keep it up to date. So you can use other Git verbs, which we'll come to later on, to keep your copy of this repository up to date. So you can track the changes that are made to this project. But because it's a clone, it doesn't give you've not got permission to write to this repository. You can't push your changes. You can't make changes to this code and push those changes up to this repository. There are mechanisms for doing that are provided by sites like GitHub, but clone is not one of them. So you can check out the code, you can even make changes to it locally, but you can't contribute those changes back to that repository. But you can also keep up with changes to this code that are made by the developers, the Broad to G80K, for example, in this particular example. Okay, so if we're working with our own repository, so we've created a repository with init, but once you've created a repository, it's not actually tracking anything. It's just an empty repository. Even if there's files in that directory, those files aren't tracked by Git until you explicitly tell Git to do so. So you use the Git verb add to track files in your repository. So the files will need to exist. They need to be actual files or directories on your file system. But once those files exist, you need to use the verb add for Git to then track those files via its version control system. So again, there's an example in our empty repository. If we touch the file called README, so that creates this empty file called README, and then in order for Git, once you've created that file, if you don't tell Git to track it, Git won't. It won't ignore the fact that it exists. It will tell you that it exists, but it won't do anything to track the versioning of that file at all until you tell Git to add that particular file to its versioning system. So that's what this second command here is doing. This git add readme is adding that particular file into the version control system. Okay, so status, so git status tells you about the status according to Git of the files in your current repository. So if you're inside a repository and you type git status, it will tell you about the current status of the files contained in your repository. So this is in the example repository which I created in the previous slides, and actually I could probably show you this live. Let's make directory lockdown learning test. There we go. Right, so show my terminal here. So I've just made a new directory called LDL test, so lockdown learning test. Okay, so this is an empty directory. It's not currently a Git repository. Okay, so if I type git status in here at the moment, Git doesn't know that this is a Git repository yet because it isn't yet. I haven't created the repository yet. So I do that with git init. So that creates this as an empty repository. There are still no files in this directory, but there is a hidden .git directory which Git created when I ran git init. Okay, so now if I type git status, it will tell me that there are no commits. I've not done anything in this repository yet. We've initialized an empty repository, but we've not done anything to it yet. Okay, so because there's no files being tracked, there's nothing yet to do. So now if I make a new file, that file now exists, but Git still isn't tracking it because I haven't added it yet. So Git will tell me that that file exists. It tells me that this is an untracked file, readme, and it tells me to use git add file to include it to what will be committed. But at the moment, Git isn't tracking it. So to get Git to track it, I need to run git add readme. And now when I run git status, Git is now tracking the file. It knows that there's a change. So the existence of this file is a difference from when the repository was initialized. So that's a change to my repository. So that's something which Git thinks I should commit. And we're going to come on to committing in a second, what committing is and what it means. So Git knows that a change has happened and it wants me to do something about that change. And that's what status here is telling me. Okay, so that's those few commands that we've looked at so far. Okay, so status is telling us about the status of the repository. Okay, got some down here. So yeah, if we create a new file but we don't add it, then status tells us that we've got this new file but it's not added. So we'd have a change to be committed. In that case, we'd have a change to be committed and an untracked file, which we've just seen in my little play with this repository at the command line. Okay, so status is quite useful in kind of letting you know exactly where you're at with your current kind of state of your repository. Okay, so commit is the Git verb which takes the snapshot, the kind of frozen moment in time of your project, of your repository. So commit is the command which is responsible for the version control here effectively. So git commit is the command, and then you can give git commit some options. So -m here allows you to define a commit message. If you don't define your commit message at the command line, Git will open its core editor. So we discussed that before when we were discussing the configuration, the Git config. Git will open this core editor and make you write a commit message. So the commit message is your description of what it is that you're putting into your repository at this stage. So having commit messages that are informative is an important part of managing your Git repository well. So here we go. Again, by way of example, so git commit. So I'm going to commit my changes to date, and I'm going to leave a message. So these should a commit message should be short and informative. Okay, so initial commit created README is a description of what I've done since my last commit on this project. My last commit, there isn't one, so that's why I'm saying this is my initial commit. So it's a short, pithy, but informative description of the changes that you've made since the last commit to this project. Okay, so there I've committed that change to my repository, and now if I run git status, Git will tell me that there's nothing to commit because I have made no changes since my last commit, because the last thing that I did was my last commit. So this is commit is Git's way of keeping track of the changes to a project, but it is a manual process. You have to manually commit your changes to your Git repository. It doesn't happen by there's no autosave in Git most of the time. Okay, so yeah, commit messages. This is an important way of documenting your project, what's in the commit, and you should be able to find a relevant point in your project's history from the commit message. The commit message should be enough to tell you about what happened at that commit, and if you ever want to roll your progress and your project back to a previous state, you should be able to identify which state you want to roll it back to from the commit message on your repository. So commit messages are very important, are a very important part of how Git works. Okay, so this is also important. So actually, for managing a repository locally, you don't need much other than add and commit, really. There's a lot of features of Git which really come into their own when you go beyond just committing to a local repository. But for managing a local repository, add and commit are all you really need. But tracking, so-called tracking and staging are different concepts to Git. So a tracked file, so a file which you have added to your Git repository, is, even though it's been added, it's not necessarily staged for the next commit. So even files which you're tracking need to be staged before you commit them. So I'll show you what I mean by that. So if we change our README file, so for instance, in this case, by echoing a line of text into it, so that's what the top line of code here is doing. We're changing our README file. Okay, so we've changed the contents of it. So we've not created a new file or anything like that. We've just added contents to an existing file. Git knows that we've done that. Git knows that we've made that change. So git status, you compare the current state of your repository to what was last committed. Git knows that there's been a change since you last committed on this repository. So it will tell you that the README file has been modified, but it says no changes have been added to your commit. So although the README file is tracked, so Git knows that the README file has changed since last time, it's not able to commit those changes because you haven't staged them. So you've tracked the file, but you haven't staged the changes, and you need to repeat git add. So git add readme will then stage those changes for your next commit. So that's the crucial part of making sure that those changes that you've made actually do get committed when you next commit on this repository. So we have to do git add readme a second time to stage the change so it can be committed. But Git does provide us with a shortcut for this. So this command, this -a flag added to your git commit, will automatically stage all tracked files which have been modified since your last commit. Okay, so you don't need to git add readme, you just need to add this -a flag when you do your next commit. So again, to demonstrate that, if we echo some text into our readme file, then Git will know that that file has changed since the last commit. Okay, so Git is tracking that file, so it knows that a change has been made. But in order to commit that change, we have to stage it. So at the moment, that change isn't staged. So if I do git commit message changed readme, Git will complain because I've not added any changes to my commit. So there is not, as far as Git is concerned, there's nothing to commit because nothing has been staged. So in order to stage that, I either have to redo git add readme, and that will stage the change, or when I run my commit, I have to add this -a flag. And the -a flag, the -a option, will stage all of the changes to tracked files that we've made since the last time we committed. So this will stage that change to the readme, which will then ensure that that readme file then gets committed to our repository. Okay, so that is that's an important feature between different commits. We have to make sure that we do that. Okay, so next is diff. So diff will show you the difference between so what's called the working tree and the index, i.e. what's currently staged for commit. So if we make a change to our file, git status will know what that change has happened, and git diff will show you what that change is. Okay, so there's an example here where we add some more text into our readme file. You're just using echo to add some text into our readme file, and then when we run git diff, Git will show us the difference between what it's calling a/readme and b/readme, where a is the readme file in the current commit, and b is what has changed since that last commit. So it's showing you that the minuses here say, well, there's less. a/readme is smaller than b/readme. There's one line that's been added in b/readme at line 2, and this is that text that's been added because it's got a plus at the beginning of the line. So this is showing you the text of the readme as it currently is, with the text that's been added in the currently not staged commit. So diff is status tells us that there are modifications, and diff will show us what those modifications are. If these modifications are extensive, these diffs can get very, very complicated and really quite difficult to understand. This is relatively straightforward to understand, but they can get much more complicated. So again, just to illustrate this, so if we echo some more text into our README and we're going to append. So we're using the double greater than symbol here to append to our README file. Again, git status will know that that file has been modified, and git diff will show us that modification. So this is essentially exactly the same as what I was showing the example on my slide a second ago. This is telling you about the difference between what's in the repository, what's been committed to Git, and what's in your current working copy of that file. And if you want to, if you're happy with this change, and if you're happy that this change it is meaningful and makes sense, then again you can go ahead and commit it to your repository like that. So again, the same commit message as before. Sorry, the same commit command as before with the -a to stage my tracked file and commit it to the repository. And now git diff will tell me that will return nothing because there are no differences between my currently committed code and what's in my working copy of it. Okay, so that's diff. Log. The name's kind of suggestive, but log shows you the history of your project, the history of your Git repository. So git log will print out an entry here in reverse chronological order for every commit to your current project. So in the case of our little project here, that's a small number of commits. It can get big and much bigger and much more complicated than this over time. Again, I can show you that here. So git log will show you the 3 commits that I've made over time. So we've got the first one, which was made at 4:28, then 6 minutes later, then 4 minutes after that, 3.5 minutes after that. You get the commit message there. You get who made the commit and when they made it. And you also get this long string of characters, which is the string which identifies this commit this particular commit. So this long string is your kind of identifier for that particular commit. And these are long because they need to be unique for every commit. You also get, it also tells you where your current repository is sat, so where your current version is, and that's what this the master version is your current working version of your code. So git log kind of illustrates this history. So these are synonymous with the Linux versions of the same tools, right? So we've come across MV and RM a lot before at the command line. They're the tools for moving and removing files, respectively. The Git verbs MV and RM do exactly the same job. It's just that they do that within Git. So once a file is tracked by Git, the version control system becomes a bit of a control freak over that file. It likes to have ultimate control over what happens to that file. So if you want to move or delete a file that's under the control of Git, that's tracked by Git, then it is best to do so through Git, to use Git to do it. So instead of using MV and RM as you would do normally at the command line, you should use git MV and git RM to move and remove files respectively. So if I move a file at the command line just using MV, Git gets its knickers in a twist, right? So here I'm moving my README file from its current location to a new name. Git does not understand what's happened. So Git thinks that the README file has been deleted, which I guess technically it has, and readme.back, this copy of it that I've created, is an untracked file. If I did this in Git, if I did git mv, Git would understand that what I've done is renamed the README file to a new, given it a new name, and that file will still be tracked. Git will maintain its tracking of that file, and will know that you've made when you make changes to it. So yeah, Git MV and also for removing files, Git RM is really important. Once files are under version control, Git really likes to keep an eye on what happens to them. So you do need to remember to move and remove files using the Git verbs rather than using the command line tools once they're under version control. There will often in a project be files which you want to ignore, that you don't want to track. So this is particularly true of large files, so data files, for example, which Git doesn't really handle very well. Git's not great for large files and for binary files where it can't see the contents very well. So if you make any change to a binary file, Git won't know what that little change is. That's why Git's not very good at Word documents, because they're not plain text. So there will always be in projects files that you want to ignore, and ignoring is controlled by the contents of this .gitignore file. Okay, so in your repository you can create this .gitignore file, and in that file you can list the files which you want Git to ignore. So for example, if we add a line which has the word data into a gitignore file, and then we download some data into a data directory, then Git status won't, because this data directory is listed in our gitignore file. Git status tells us nothing about it whatsoever. It doesn't include it in the untracked files, because as far as Git is concerned, that directory doesn't exist, because it's in the .gitignore file. So that can be a useful tool for not just for what you want to track, but what you don't want to track within a repository. And there will often be files within a repository that you don't want under version control. Okay, so reset. So reset can be used to roll back uncommitted changes or to revert to an old commit. So reset is the way that you can undo changes that you've made that you perhaps didn't want to make. Okay, so so here's a good example on this slide, and let's show you that in real life as well. Okay, so if we do something destructive, so in this case we're accidentally overwriting our README file. Okay, so instead of using 2 greater than symbols, we've just used 1. So we've overwritten the contents of our README file. But then, because we're good little citizens, we've committed our change once we've made it. But then we realise after we've committed it that we didn't mean to do that. We meant to append that text to the end of our file. We didn't mean to overwrite the file with that text. Okay, so let's go ahead and do something like that to our example repository. So if we echo hello world, and we're going to overwrite our README. Okay, so now if we have a look at the README, you can see that it only contains the text hello world. If you look at the diff, git diff, you can see that we've deleted 2 lines of text and we've added 1 line. That's what the diff is telling me here. But then we go ahead and commit it. AM destruction. Okay, so that's a destructive change that we didn't mean to make, but we've committed it anyway. And now we realize what we've done. Okay, so we've committed the change, we realise what we've done, and we want to roll that change back. Okay, so we want to get back to the previous version of our README file. We can do that using git reset, and that's what these references are for. Okay, so this this big string of hexadecimal here is a reference to a particular commit, and we can use that reference to roll back to that particular commit using git reset. So to show you the example in my slides, so git reset is a hard reset, so we're just going to go revert back to that version of the file that we had, that version of the repository that we had before. That's what this command will do. So let's do the same thing here. So git reset -- hard, and we want to reset to this second change here, so this third commit. So that's this one. So we'll copy and paste that into there. There you go. So that has rolled me back to that previous version of my repository, and that has changed my README file back to what it was before I committed my previous change. Okay, so it's taken me back in time to my previous version, and this is what we mean by version control. We have control over the versions of our repository, and because we did a hard reset, the unwanted commit has disappeared. It's gone. Okay, we've reset to a previous version of our repository, and that hypothetical future version no longer exists. Okay, so that is a useful way of dealing with those kind of problems that can occur quite naturally when you're working with files. It can be very useful. Okay, so everything that we've done so far has been with a local repository, but Git is a powerful tool for collaboration, and remote repositories can be used to enable Git as a collaborative tool. So at the moment, all of the things that I've done have been on the disk of my laptop. I've done nothing in any remote setting whatsoever. That although that directory is under version control, if my hard drive dies overnight, I will have lost all of the work in there because it's not backed up anywhere. It's not saved anywhere other than on my local disk, which is also a problem if you want to collaborate with the contents of that repository, because obviously if it's on my disk, you can't access it from where you are. So Git as a collaborative tool. So version control has been used for donkey's years as a means of collaborating on code. The way that this used to be done is via a central repository. So slightly older version control systems, like for example Subversion, you have a central repository on a Subversion server somewhere, and everybody downloads a copy of the code from that central server. They make local changes, and then they send their changes up to the central repository, and that central repository is changed for everyone. Git, on the other hand, is a distributed version control system, and this means that everybody has their own copy of the repository, and they can make their own changes to that repository. They can make their own what are called forks, and then if they want to, they can then push those changes to the central repository. But this is not required for Git to work as a version control system. This is not explicitly this push and pull thing here is not explicitly required. You also don't need a central repository. You can push and pull to other people's local repositories as long as you can access them. So you can also, as well as pushing and pulling between the central repository, you can also push and pull between other people's local repositories. So this is what we mean by Git as being a distributed version control system, is that the idea of where the repository sits is a distributed thing. It could be anywhere on anybody's computer. It doesn't have to necessarily be this central repository. Which brings us to GitHub. So GitHub, which we have encountered on Lockdown Learning before, and we have a repository there with the code that we've written in our Lockdown Learning sessions. But GitHub will often perform the role of this central repository for Git repositories, this central server. So GitHub, actually increasingly GitHub is free. Microsoft bought GitHub about 18 months, 2 years ago. And since they acquired it, they have actually made more and more bits of GitHub free. So a free account on GitHub now enables you to do an awful lot of stuff, including having private repositories and being members of teams and all sorts of other things. GitHub also provides educational accounts. So the bioinformatics support unit team on GitHub was set up as an educational account, so is also completely free to use and has lots of enterprise features. And the kind of step that GitHub really made for managing code is are these social features that it has for organizing collaborations around code. A couple of which I'll mention here, but is not really the point of this introductory session. Okay, so getting set up with GitHub. So you need to sign up for an account. So you go to GitHub and create an account. Once you're signed in, then you can create repositories on the site. So you can create new GitHub repositories. So for instance, I'm signed into GitHub here. This is my GitHub site, and indeed this is actually I was going to mention this later on, but this is the Git. This repository here is actually the slides that I'm working my way through in my other browser window. So these slides here, which is an HTML slideshow, is actually under version control and is on GitHub. And this is a public repository, so you can download these slides. And I'll come to that a little bit more shortly. But yeah, so this is a repository for these slides. Once you've created your account and you're all set up on GitHub, then creating a repository is relatively easy. You click this plus, and then you go to new repository, and that will create via these steps here. This will create a new repository for you on GitHub, so on their website. So let's just go ahead and do that. Let's create a repository called LDL_test under my account. Give it a description, a test repo for learning Git. I'm going to make it public. I'm not going to initialize it with a README or anything else. I'm just going to click create repository, and this will create an empty repository on GitHub. Okay, so there we go. We've created that repository, and once you've created it, GitHub gives you some setup that you can do for this. So once you've got your repository on GitHub, there's some instructions here for essentially adding an existing repository that you have to this repository on GitHub, which is what we're going to do in a second. Okay, so that's our new repository on GitHub. So once you've set up a repo, you can initialize a repo. You could put a README into it, for instance, and then you can clone it. So we could take a copy of it onto our local system using git clone. And if we provide our login credentials to our Git command line client, we can then use Git, as well as tracking the changes in that repository. We can also use Git to make changes to it, because Git knows about our GitHub account. And so, but this is the other thing that we can do is with an existing repository, you can set an existing repository up with a new empty GitHub repo. So that's what we've just created a new GitHub repository. This command here, this git remote add, will add a named remote repository to your local repository. So in this case, we're adding a remote repository called origin, which is at this particular place, git@github, : whatever your username is, / whatever your repository is. And this is the code which GitHub gave us on its website when we created the repository. So we have that code here. So git remote add origin So this is the default name of the remote location, and then this is the magic that we need to actually add this location on GitHub as the remote location for this repository. So if I copy that to my clipboard and then hop across to my command line and paste it in, this will add that remote location to my local Git repository. And now what I can do is I can take the code that I've got locally and I can what's called push it to GitHub. So to get this code up to GitHub, I need to type git push, and then it's the place that I want to push it to. So the place I want to push it to, I named in the previous command. So when I added my git remote, I added this origin. That's the name of the place that is my remote. So that's identified by this URL here, effectively. So origin is the name of the place that I want to commit it to. And then the final bit of the push is what it is that I want to push. And that specifically is the branch of my repository that I want to push. And the branch that I'm currently working on is this branch called master, identified up here. So that is the branch that I want to push up to GitHub. So I want to git push to this place called origin, my current branch called master. And that is my command, which will then transmit the code in my local repository up to GitHub and will reflect my local repository up there on GitHub's website. So that push has now completed, and I'm just going to pop back up to GitHub, which is in this state of my empty repository, because this is the state we left it in. And if we refresh this page, so I'm going to click refresh here, you will see that we have now have a README file. So this repository now looks like the our local repository. It's got the same contents as our local repository. And indeed, it's got all of the history of our local repository as well. So you can see that Git understands that this repository has had 3 commits to it, various other things. So Git also has inherited the history of our repository as well as just the single local commit. That's getting us stuff up to GitHub. In order to do that, I had to set up my authentication with GitHub correctly, and I'm going to go through that later on. I'm going to later on in talking about Git, I'm going to set up a repository on the VM, and we'll set the VM up to authenticate against GitHub. So I'll show you how that works later on. Push we've just done. So git push the remote name and the branch. So the remote name by default is origin. That's kind of the standard name for your remote, but you can call it anything. So we could, when we added our remote at our terminal here, we could have called it something different. So we could have done git remote add GitHub and then the GitHub URL, and then our remote would have been called GitHub and not origin. So you can affect that name, and the same as the branch that you're working on. By the default branch that Git creates is called master, but you can change that branch at any time. And again, something else that we'll go through later on is how branching works and how to make a new branch and change your branch. So that could also be different as well. It doesn't have to be master. But once you've pushed once, Git is nice and convenient for you. Once you've pushed to a remote location once, Git will fall back on that last remote name and branch the next time that you want to push. So just typing git push the second time will suffice. Pull downloads the latest updates from your remote repository. So very similar to push in terms of its grammar. And if you're collaborating on a repository particularly, so if you use a repository with more than one, if it's not just you that's working on a repository, or if you work on a repository in more than one place, it's good to get into the habit of pulling before you start to work on that in that repository. And again, once we've set up a copy of this repository on the VM, I'll demonstrate pushing and pulling and how that works. Okay, merge is, so if two committers if two people are working on a repository, or even if you're working on a repository in two places and you've made different commits in those two different places, in other words, you haven't pulled before you've made changes, then those commits will have to be merged. And even if there's no conflicting changes, even if they're completely disjoint commits in two completely different files, you still have to manually merge those changes before you can sort of continue to work on your repository. So merging can be easy, but otherwise it can be, especially if they conflict, if your two changes conflict, it can be slightly tricky. So the general 4-step guide is to use git status to find the conflicting files, edit those files manually to a version that is no longer conflicting, then use git add to tell Git that you've resolved the conflict, so to stage your new changes for a third commit, and then check with git status that the staging has worked properly and commit your changes. So that general 4-step guide will get you through an awful lot of conflicts in Git. To mention these features of GitHub, and they're a bit beyond scope, and I'm not going to go into any more details about these, but there are features of GitHub that are designed for collaborative working. So forking allows you to make a copy of somebody else's repository on GitHub, which you can then clone locally and make changes and commit those changes, push those changes up to GitHub. Once you've made those changes, you can then request that they're merged into the parent repository via a pull request. So this is the primary methodology on GitHub that allows you to collaborate, particularly large collaborative projects where you might have lots and lots of people who want to make changes. You don't want to give them all write permissions to your repository all of the time, so you allow them to fork, make changes, and then submit a pull request to get their changes merged into the central repository. Okay, GitHub Desktop. This is a convenient application. So it's a graphical user interface for Git and particularly for GitHub. And I will go into a little bit more detail later, but just very quickly to show you GitHub Desktop. This is GitHub Desktop, and it currently has the LDL test repository loaded in, so you can see that my current repository here in the top left is listed as the LDL test. It's up to date with the repository on GitHub, and I'll show you what happens if we change it in just a second. So this is all set up to be my managing this repository which we've created. And if I make changes in that repository, so if I for example, if I add some extra text to my README file, so let's echo a change into my README file. So this will make a change, add an extra line into the README file. Now git status knows that I've made that change, so it knows that the README is modified, and GitHub Desktop uses git status as well and shows me that this change has occurred. So GitHub Desktop knows about this change and it illustrates this change to me. So it highlights the change, shows me the file that's changed since the last commit, and actually shows me the diff as well. So this is the diff that we were seeing these diffs earlier using git diff, and it's got, because it knows there's a change, it's prompting me here now to commit this change into my repository, and it's actually even given me a suggested commit message here. If you only ever use these suggested commit messages, that your commit messages would be quite boring, but they can be quite useful from time to time. I'm just going to add my own, which is not a terribly helpful commit message, but nevertheless. There you go. That's my message, and I'm going to hit commit to master here. This button that will commit that change. So that's like me running git commit with a message at the command line. And now that I have made a change locally, GitHub Desktop also knows that I am out of sync with my remote. So it's prompting me here in the main window to push my commits to my remote repository. So I'm going to hit push origin here, and this will take that change that I've just made locally and will reflect that change on GitHub. And so it's just making that change, and again, just check git status just to show you that that has changed. So although I've done nothing at the command line, my status has changed because I've made the commit in the application. And if we go back to GitHub and refresh, you will see that that change has now been pushed, and the README you can see has changed to reflect that change that we made locally. So GitHub Desktop is a very useful application for working with Git graphically, so you don't necessarily have to know all of the command line incantations to be able to work effectively with Git. I'm going to look at RStudio a bit later on, so I'm going to come back to interfaces with between Git and some other software tools. So I'm going to come back to RStudio a little bit later on in the session. It's worth mentioning here that all of the content up to this point does follow this textbook very closely. So it's an O'Reilly book written by Vince Buffalo, who's a bioinformatician in the States, called Bioinformatics Data Skills, which I thoroughly recommend to beginner bioinformaticians. And I realise I haven't really mentioned it before, but it is a very good book and worth pursuing. So this is kind of the end of part one, and what I'm doing, there's a little bit of post-production going on here. So those some sharp-eyed viewers may have noticed some weird jiggery-pokery with dates, and maybe my cuts and things may not have been terribly smooth. I've just inserted this piece in between two separate live videos that I made on YouTube. The second live video I'm going to stitch on after this, so that it forms one big long introduction to Git, and I've tried as much as possible to get the continuity right, but this is kind of the end of part one, and this video will go straight into part two. How smooth that's going to be depends on my video editing skills, which I will fully admit are probably not great. So I will see you imminently in part two, and that will go through some extra bits and pieces to do with the basic use of Git, and particularly interacting between Git and GitHub. And that will follow immediately after I press stop on this recording. This is a repository on GitHub which contains the contents of the repository that we were building last week by way of example. So it contains, at the moment, just a README file, and that you can see that README file because GitHub is clever. It shows you the contents of the README file, because the idea is that if there's a file called README, that is the first place that's going to describe a project, and so GitHub extracts the text of the README file and shows it to you. If your README file has Markdown in it, and we talked about Markdown in the context of R Markdown a few weeks ago, if your README has Markdown in it, GitHub interprets and renders that Markdown as well. So GitHub's quite clever about the way that it deals with README files. But that is the only contents of that project as it currently stands. This one file with these 3 lines of text. But our GitHub repository is exactly up to date with our remote repository as far as GitHub is concerned. That is our repository on our local machine. Okay, so the 2 things are currently in sync. And what we can then do, so now that we've got things set up properly and I've got my authentication sorted, now I can make changes locally and then reflect those changes in my local repository by careful use of the correct Git commands. So let's say we're going to create a script in our repository. Okay, so let's make an entirely new file. So we're going to use nano to make an entirely new file. We're inside our Git repository, so you can see in my terminal here, my current working directory is home/code/ldl test. This is my local copy of this Git repository. If I do ls with the -a flag option, you can see that we have our .git directory in this current working directory. That's the thing, if you recall from last week, that .git directory, the presence of that defines this as a Git repository. And Git understands that the presence of that directory and the things that are in that directory are what define this as a Git repository, and also define the status of this Git repository. Speaking of status, we can check on that with the command git status. That will tell us what the status of our current project is. Now that we have remote as well, so Git is reporting nothing to commit because we haven't made any changes since our last commit. It's also saying it's up to date with the remote, where the remote here is called origin/master, which is the default name of a remote repository. Okay, we can so we can now make changes to our repository. So we're gonna, as I said, we're gonna create let's create an example script, and it's going to be a bash script. So so it's a bash script. So #bin bash, then echo. Okay, so we've been here before. Okay, very simple 1-line script to echo hello world. We're going to add this into our repository, commit it, and then we're going to push that change up to GitHub without leaving the command line. Okay, we don't need to leave the command line to do this. So we're going to save this file, Control O, and then exit nano, Control X. And now when we type git status, we will find out that we have an untracked file. That is the example script.sh file that we just created. So that's now an untracked file. Because we've created it, we've given it kind of, well, the fact that it exists is enough for it to be an untracked file, but we haven't staged it. We haven't told Git to track it yet. So it's a new file that Git isn't currently tracking because Git doesn't know about it yet. So in order to get Git to track it, we need to use git add. So we're going to do git add and then the name of the file that we want to add. And now Git will be tracking that file. So there you go, we have a new file, and this is a change which we are now able to commit to Git. So we've made this change, and now we can use git commit with a message. So let's say added example script.sh. Right, descriptive commit that lets us know what it is that we've done. So that's our message, and this will commit this change into our repository. So this will effectively take a new snapshot of our versioned repository. So there you go, we've added that new file in. And again, if we do git status now, so git status is this command that you keep coming back to that tells you where you're at compared to sort of where you're at in terms of your current repository. So now git status is telling us that there is nothing to commit. Okay, so nothing to commit because we've made our change, we've added it, and then we've committed it with an appropriate message. But the other thing that git status is telling us now is it's saying that my branch, so here my branch here is ahead of the remote branch origin/master by one commit. Okay, so this is telling me that my local branch now is ahead of my remote, and that in order to catch up, in order to publish my local commits to my remote, I need to use git push. Okay, so if we take another quick look at GitHub, so let's bring GitHub back up, just to show you that nothing has changed, right? So I can refresh GitHub. So if I hit refresh in Chrome, I can refresh GitHub and nothing has changed. Okay, there's no, although I know that locally I've made a new commit, GitHub knows nothing about that commit. So this is a change which currently has only happened locally. Okay, so how do we get that change up to GitHub? How do we get it up there? And the answer is, well, we push it, and we push it using git push. So by default, what you have to do is tell Git the remote that you want to push to, so that's origin, and the branch at that remote that you want to push to, which in our case is master. Okay, so git push remote branch, so git push origin master, and that will push this version of our current local repository to our remote repository, which is my GitHub repository in this case. If the last time you pushed to origin master, you don't need to include origin or master in this git push. It will, by default, Git will push to the last place you pushed to. So unless you're changing your remote, and a repository can have many remotes, so unless you're changing which remote or which branch at that remote you're pushing to, you don't need to define it at the command line. So I have pushed to this repository before, and the last time that I pushed was to origin master. So git push will suffice for taking those local changes and reflecting them on my remote repository. And my remote, if you remember, we added it last week. My remote is this repository on github.com. Okay, so that's defining my remote there. So now if we bring GitHub back into focus and refresh the page, what you should now find is we've just pushed. So we committed this 4 minutes ago. We've just pushed it. And that change has now been reflected on the GitHub website. So that script that we just created, we've pushed it up to our remote repository, and there it is now on the GitHub website. And I can click through, and you can see that the content on the GitHub website is exactly the same as the content on my local machine. Okay, so this change didn't take effect until I ran that push. So until I took my local commit and pushed it to my remote repository. And that is always true. That's always the case. You need to actively push your changes to your remote repository. Git won't try and take care of that on its own by default. So the other thing that we need to think about is then changes to what's in your GitHub repository that aren't necessarily reflected locally. And there's ways that this can happen. You can add users. You can give other users write privileges to any GitHub repository that you own. So GitHub is a collaborative platform. So you could give your lab mate write privileges to your GitHub repository so that you can collaborate on code together. And so they could be making changes to your code. And you might want to catch up your current version, your local version, with any changes that may have happened on GitHub since the last time you worked on the code. It could also be that you want to work on your own code in multiple places. So it might be that you want a local version on your computer at home and a local version on your computer at work, and you want to keep those two versions in sync. So you might do some work at home in the evening, commit that work to GitHub, and then in the morning you might want to catch up your local copy at work to the version at home. Now obviously at the moment, depending on various states of lockdown and whatever, and as I said, a week's a long time and a lot's changed this week in the UK anyway, but for me there's no distinction between home and work at the moment, so I don't really have that issue. But there's a computer on my desk at work. It's a desktop computer. It doesn't come home with me, and I could see situations in which I would do a little bit of tinkering in the evening and want to catch my code up in the morning when I get to work. And so you need to be able to deal with situations where your remote has changed and your local therefore is out of sync. So we can simulate this just quickly by making a change on GitHub. So GitHub lets you edit the files locally, so I can make changes on GitHub, and GitHub treats these changes as Git commits. So it's under the hood, GitHub is using Git to track these edits as I make them. So I've pressed edit on this file on the GitHub website, and I can make changes. Okay, so I can say sleep 10 and then echo all done. Okay, so just a couple of extra lines. And then on GitHub I can commit this as a change. So this is a website-based interface to Git, essentially, where I can take this change that I've just made to this file and I can commit it, and I can give it a commit message. So I have updated example script with a sleep. Okay, a little bit descriptive, not too long. Commit directly to the master branch. I'll talk more about branching shortly. But this creates a commit on my master branch. Now my GitHub is different to my local. Okay, so my GitHub version of this repository, my remote, has changed. So this is my example.sh script, which is different now to the version in my local. I've now made 6 commits, whereas before I'd made 5 commits. My last commit, you can see, was 24 seconds ago. This repository on GitHub is now different from the same repository that I have stored locally. And so we can show that, and this should work. If I do git status, now it's telling me I'm up to date. And this is the thing where it's slightly misleading. Actually, I'm 1 commit behind. But I don't know that I'm 1 commit behind because you're not automatically updated with it like you are before you push. But in order to get up to date, I have to do the opposite of push, which is pull. Okay, so git pull, again, git pull origin master would be the full command, assuming that you want, in the situation especially where you wanted to pull from a different branch or a different remote, you would have to be explicit about it. But the last time we used a remote repository, it was origin master, so we're sticking with the same thing. So we're doing git pull. So there you go. That has pulled down the change from GitHub. So we've updated from the commit we were at locally to the new remote commit. That's this identifier here, which we can check on GitHub. There's the ID of the commit, 0b12598 on GitHub. And you can see that that's the same, that's this 0b12598 is the same ID of the commit here. So we've shipped forward to this commit that was on our remote repository that wasn't on our local repository. The number of files hasn't changed. We've still got the same files as we had before, but our example script has changed. Okay, so I've not touched that file in my terminal, apart from via Git. It's Git that has made the updates to that file via git pull. So by pulling the remote changes, I have updated that that file using git pull. Okay, so that is push and pull, and push and pull are obviously, when you're working with GitHub, they're extremely useful. And GitHub is really, for most people using GitHub is going to be the platform that enables collaboration via this system. So GitHub is going to be the way in which you and a coworker or a collaborator can work on the same set of files and keep up to date with each other. And Git is hugely useful for that. It's very, very useful for enabling that kind of working. The only thing where you get into where things get sticky is where you and a co-worker have made changes between syncing up repositories. You and a co-worker have made changes in the same file, and that is where you'll end up with what are called conflicts, and you need, before you can carry on working with your files in Git, then you need to resolve those conflicts. It's usually fairly easy to do, because usually people are working on different bits. Even if it's in the same file, they're working on different bits of the same file. But when things conflict, that can be problematic. Does git pull overwrite local files? Yes, it will do. Although sometimes you'll get conflicts as well, I think, and it might be worth testing that. What I am just gonna do over the next 5-10 minutes is I'm going to try to set Git up on my VM to try and kind of simulate two people working on the same code in two different places. So I can make edits on GitHub, and that kind of shows you how that works. But there's nothing quite like having the same repository in two different places. So therefore, that's RStudio. Where is my VM? Here it is. There we go. So here's my VM. So it's my lockdown learning Ubuntu 1804 VM, which we've used time and again. I'm going to open my terminal, and the first thing that I'm going to do is I'm going to install Git, because what you will find is that by default on Ubuntu, Git does not come pre-installed. So we have to install Git. So sudo apt install git. So that's exactly the command that that Bash recommended to me when I tried to run Git without it being installed. So prompted for your password, so enter your password, and that will install Git and the dependencies for Git that are required for it to work. So what happened there? Do you want to continue? Yes. There we go. So now apt is installing Git for me. There we go. So we should now have Git installed. So what I'm going to do is I'm going to make a directory. I'm not going to do this in my share directory because I don't want to confuse the issue between files that are shared with my host machine and not shared with my host machine, because obviously all of the Git stuff that I've done recently has been on my host machine, so I don't want to get those two things confused. So I'm going to make a code directory. I'm going to cd into there, and then I'm going to clone this repository from GitHub. So actually the other thing I want to do, bear with me a second. There we go. So we've got a new installation of Git, so we need to set it up. So we're going to do git config global. So I'm going to change the global config. I'm going to add a user name, user.name, my name, then git config global user.email, email for Git purposes, which is, it's important that it matches the email of your address, the email that you use at GitHub, for instance, if you're planning to work with GitHub. I'll just add git config global color UI true, and git config global core editor, and I'll set it to nano, so that if we're dropped into the editor, if I forget to put a commit message in and we're dropped into the editor, then it's an editor that you're familiar with. Okay, so that's my config sorted, which is important. And now what we're going to do is we're going to clone this repository from GitHub. So there we go. Here is the GitHub. You've got a button on here which is clone, and it gives you, in here, gives you a URL for cloning it. So this string here is what you need for cloning this repository. So you do git clone and then this string in here. So here we go. So git clone, and then it is git at github.com :username / repository name, which is ldl_test.git. Okay, so the general form here is always git at github.com and then a colon, and then this is the name of the repository. So in this case, it's my username / repository name, and then it finishes with .git. And that is the general form for taking a copy of a repository from GitHub. Okay, so this is the first time I've used Git. Here is using SSH, so secure shell, to take a copy of this repository. It's the first time I've connected on this VM to GitHub over SSH. So it wants to check that I'm confident that I'm doing the right thing, which I am. So I'm going to hit yes. Right. And so because what I'm doing here, and actually this time I've done this deliberately, is I am hitting the same authentication problem on GitHub that I hit last week, which is that as far as GitHub is concerned, this machine that I'm using, this virtual machine that I'm using, doesn't have access rights to this repository on GitHub. It's not set up correctly so that I'm able to access this particular repository on GitHub. And the way that GitHub manages this is via what are called authentication keys. And so what you need to do is set up a pair of authentication keys on your VM and then give GitHub a copy of the public key. So a authentication key comes as a pair of files. There is a private file which you keep private, that you let nobody else see. And then there is a public file which, as the name suggests, doesn't really matter who gets hold of it. It doesn't matter who has that public key, as long as you keep your private key private. And so you give the public key to GitHub, and as long as you've got the matching private key, then GitHub can pair those two things up and can know that you're authorized to access this repository. So we're going to generate a key pair, and we're going to do that using an executable, a binary on Ubuntu, which is called SSH keygen. So this is a tool for generating an authentication key pair, so SSH keygen. Okay, we're going to generate, so -t is the type of key that you want to generate. We're going to generate a type of key called RSA. There are lots of different types of key, but RSA is the one that's probably most commonly used. And that should be all we need to do, actually. So we'll run that, and we're going to enter a kind of interactive prompt with our command line now. So here we go. So we're being told here we're generating a public/private RSA key pair. Enter the file in which you wish to save the key. So by default, the private key will be in a file called id_RSA in a directory called .ssh in your home directory. Okay, so this is by default where your private key will be stored, and that is a perfectly fine place to put it. The public key will be stored in the same location, but will be called id_RSA.pub. Okay. You can protect your key pair with a password, which is always good practice, to protect your key pair with a password. For most systems now, once a key is protected with a password, your system's password manager will kick in and remember it for you. But just in case, use a password that is memorable to you. So I'm going to stick a password in here because that's good practice, and you have to type it twice. So never generate a password that isn't protected. Never generate a key pair that isn't protected by a password, because then even if you lose your private key for whatever reason, it's still password protected. And it's not a key that will let anybody access systems where the public key is stored. Okay, so that's my key pair has been generated. Okay, so your identification has been saved in /home/simon/.ssh, which is a hidden directory, /id_RSA, and it says the public key has been saved in home simon.ssh id_RSA.pub. Okay, and it's this public key, that's what we're going to give to GitHub for authentication purposes. You should never ever distribute the private key anywhere. That is your file to keep safe. Leave it where it is. Leave it in your .ssh directory, because that's where your system knows to look for it. But that is that always has to be kept safe and secret. Never spread that file around. The public key, on the other hand, is your kind of, that's the second half of your authentication key, and that is the bit that you can pass on to other people. Okay, so let's just have a quick look in our where's my tilde? There we go. In my home.ssh directory, I now have these two files. This is my private key, which I'm not going to look at. This is my public key, which I can show you the contents of. .pub home/.ssh. Okay, so that is my public key, and if you've generated a key pair, your public key should look similar with a similar amount of gobbledygook inside it. And what we want to do now is to provide this public key to GitHub, so that GitHub knows that this machine belongs to me and is authorized to access this particular repository. So to do that, we're going to log into GitHub. Actually, what I'm going to do is I'm going to put that into my paste buffer, copy, and then I'm going to go to my browser. What we're going to do then is we're going to add this key. So we have to go into my I think it's settings, and then here SSH and GPG keys, and we have to add a new key. Okay, so we're going to put in a new SSH key in here. The title is Lockdown Learning, and the key is what I've just copied and pasted out of my so this is the public key that I just copied out at the command line. Okay, so I'm going to add this key. So this is the public key, very definitely the public key. I'm going to add this to my GitHub profile. That will trigger an email. I will now receive an email from GitHub. There you go, it's arrived, telling me that I've done that, informing me that I've done that. But the upshot of it is that now this machine will now identify itself correctly to GitHub when I try and do anything at GitHub. So now when I run git clone, there you go, it's prompting me for the password. This is not for my login to GitHub or anything like this. This is the password for the key pair that I just generated using SSH keygen. So I put in a passphrase when I made that key, and that's what it's prompting me for there. So I've entered that passphrase, and now Git has cloned that remote repository for me into my present working directory. So after git clone, I now have a copy of that repository here. I can cd into it. It's just a normal directory. It has the .git directory that's going to be very similar to the .git directory on my local machine. It's got the README file. It's got the example script. Okay, so let's make a change. I made this change on my VM. Okay, save it. We don't need to add it because we can do git commit. It's not a new file, so it's already tracked. We just need to stage the change, which we can do in commit with -a, and then we give our commit message a change on the VM. Okay, so that's our commit message. So let's commit that change. There you go. So that's a commit, and now you'll find that we're a commit ahead of the remote, because by cloning, we automatically added a remote to this repository, because this repository comes from a remote. So we can, because it's a clone, we can git push and it will push to the place it was cloned from. Okay, so git push authentication will now work because we've set up our key properly. So now we can push to the remote location quite happily. And now if we bring our GitHub back up, here we are, and refresh. So I'm going to hit refresh. You will see that the change in the README was a minute ago. The commit message is a change on the VM, and we've got in the README we have the text that we added on the VM. Okay, so we've made the change on the VM, we've committed it, and we've pushed it to the remote repository. And now we're going into work the next day, and we know we've made those changes, or that somebody has made those changes since the last time we worked on our repository. So our local repository on this machine. So now I'm back on my host. I'm on my Mac, in my Mac terminal here. This repository is out of date. Okay, so I don't have that change that I just made on my VM in this repository, but I pushed it up to GitHub, so I can get that change, and I can get that change again via git pull, because I can fetch it from GitHub. So there you go, it's pulled that change down, and now my README file again reflects that change in the remote repository. Okay, so that enables me to work very effectively between two or even lots of machines. And as long as I remember, before I start working in a particular place, to use git pull to get the latest version, then we keep everything in sync. And especially if it's just you working on a repository, it should be relatively straightforward to keep things in sync. Okay, I want to talk about a couple of other things before I finish. The first of those is branching, which you can use to experiment with new things, and if they don't work, you can throw them away. If they do work, you can merge them back in. So it's a fairly common way of working with version control. So I'm going to talk very briefly about branching, and then I'm going to talk about I'm going to come back to clients. I mentioned clients last week, but I just want to come back and talk again about clients for Git before the end of today. Okay, so the first thing is branching. So Git, this is a verb for Git, which is branch. If you run it without any other arguments, it will just list the branches that are available in your current repository, and it will highlight the one in which you're currently working. So by default, when you initialize a new Git repository, the initial branch that you're working in will be called master. Although there has been talk, and I don't know if this has been implemented yet, but there has been talk recently of that terminology changing because of the negative connotations of that particular word. And so there's every chance that this video is going to be out of date very soon if it isn't already. And that they've changed the terminology of the default branch in Git and on GitHub. But for our purposes right now, at the moment, that is, for better or worse, that's the name of the default branch in a new Git repository. If you want to create a new branch, okay, so Git branch, and then you create a new branch, and you do it just by naming it. Okay, so we're going to name our branch. I'm just going to call it new branch. Okay, just for by way of example. So this creates a new branch on your repository, and now you can list your branches again by doing git branch. And if you look, you can see that at the moment our active branch is still master. Okay, it hasn't changed, and that's because you have to activate your new branch to work on it. And you do that via checkout. So git checkout, and then you define the branch with -b, and you say, well, I want to work on this branch. Now, the reason for doing this is it might be that you want to experiment with something new and you're not sure if it's going to work, so you want to test it, but you don't want to test it in your main repository because maybe there's other people working in there and you don't want to pollute what they're working on with your new feature. Now, this is not necessarily often something that you will do if you're working in a repository on your own, but particularly if you're working with other people, having multiple branches can be a really effective way of keeping check on. Okay, sorry, you didn't need the dash B. The dash B would have created the branch if it didn't exist already, I think. But anyway, branching can be a really effective way of kind of keeping track of new things. It's also effectively what's used to do forks and pull requests on GitHub. It's the same kind of methodology. Okay, so we're in our new branch now, and we're going to want to start working on our new feature. So let's have our new feature script. Okay, so in here we're going to have a brilliant new experimental feature that's going to advance the field of bioinformatics by 10 years in one fell swoop. Because I have no imagination. There we go. Okay, so there you go. There's our brilliant new feature. So that's in our new branch. And now if we need to add, so hold on, let's get status first of all. Okay, so there's one new untracked file. This is behaving exactly the same way as status behaved on the master branch, and that's because we haven't yet, we're not yet in a position to, we haven't made any changes as far as Git is concerned to this repository yet. So we can add our brilliant new feature, to our Git repository, and we can commit it. With a message, new feature added. Okay, that's committed. You'll notice that this branch here isn't reporting anything about a remote, and that's because this branch is not connected to the remote. So it's slightly beyond the scope of what I wanted to do today and would take too long, but you can add the branch on GitHub and add it as a remote and have that branch synced up on GitHub as well without too many hassles using the techniques that we've already explored. Okay, so that is we've been working on our new branch. We've written some new code. We've committed it to our new branch, and we think this is the best thing since sliced bread. We've advanced the field of bioinformatics by 10 years in one fell swoop. So we want to get this feature into our master repository and quickly. Okay, so let's switch back to master using git checkout. Okay, so that switches us back to our master repository. And now if I list, what you will see is that our new feature script has gone. It's not there because it doesn't exist on this branch of the code. But no fear, we can switch back if we want to. So we can check our new branch back out, and we've got our new feature back again. But we can also merge them together. We can also merge our new feature script into our master branch, and I'll show you how. So we want to check out master again. Okay, git branch, just to show you what's going on. And then we want to do git merge, and then the name of the branch that we want to merge into this branch. So we want to merge new branch into master. And there you go. So that is what has now happened, is Git has merged our feature branch into our master branch, and we've acquired the new feature script in our master branch. So we're still on the master branch, and new branch still exists, but the two things are now in sync. Okay, so we've synced them up, and our new feature is present in our our master branch. And you could now go back into your new branch and you could work on another new feature and continue to make new developments there before merging it back into master again. Or you can delete that branch. So you can delete the branches as well with git branch and -d. -d will delete a branch, a named branch. This actually does take me quite nicely into interfaces, interfaces to Git as well. I showed you briefly last week the GitHub desktop application for Macs, and it's also available for PCs. I'm just going to swap branches again just to show you okay, so I'm going to check out new branch again, and even though there's no differences here, I'm going to show you the current status of my GitHub desktop app. Okay, so this is the GitHub desktop app. I've got the current repository is LDL test. That's the repository we've been working in. There are no local changes, so there are no uncommitted changes in this repository. Although that's not strictly true. I haven't pushed my changes to GitHub yet. But anyway, what you can see is that it is saying there's a new branch. So the current branch, new branch, hasn't been published to the remote yet. By publishing it to GitHub, you can share it, open a pull request, and collaborate with others. Okay, so the GitHub desktop app has detected that I've created a new branch, and that I'm working on a new branch, and it's offering me the ability to publish that branch up to GitHub. And so I'm going to click that button, and it's going to push that branch up. So it's just quickly working on that there. There you go. And now, if we bring GitHub up, you will see that, there we go, I've got some changes. So it's saying new branch had recent pushes less than a minute ago. So we can compare, we can do a pull request on that branch, we can switch to it. So now it exists on GitHub with that new script in it. We can switch back to master if we want. In the GitHub app, so GitHub desktop, here we are, here's GitHub desktop. We can switch to the master branch. There you go. The master branch is up to date, is committed, up to date, but it is now out of sync with the remote because we've got the new feature script is committed to our master branch, but it's not pushed. And the GitHub desktop app knows that. So now we can push that change up to GitHub as well. And this interface, once you get used to it, is a really effective interface over the top of Git, and avoids you having to necessarily remember all of the different kind of command line tools and everything that you need to run with Git. So let's just recheck out our master branch in our command line, and let's touch a new file. And if we then flip to the to the GitHub app, you will see that new file has been added. So it's here, it's a new file, it's empty, but it's a new file, and we're being prompted to commit this change to our master. And we actually get a default commit message here. So create new file is like a default commit message, which we can use. So let's commit that. Now the GitHub Desktop app knows that this is out of sync with the remote, so we can push our origin up to the remote, and off it goes. And okay, one last thing then. Here we go. We go back to GitHub and refresh. And there we go. We've got the new feature script is here. We push that up using the app. A new file is here as well. And we push that up using the app. I just want to quickly mention two other things. The first of which is a text editor. So the only text editor we've really talked about so far is Nano. But there's a whole world of text editors out there. A lot of them are a lot cleverer than Nano. One which I use a lot locally is actually made by the people at GitHub, and that's a text editor called Atom, which you can download from atom.io. So it's developed by GitHub, the company GitHub, and that means it integrates really nicely with Git and GitHub. So I'm just going to quickly pull up Atom. So I'm just starting it. Here we go. And so here is Atom, and I've opened a project. So you can add a folder in to a project, and that brings up this little pane on the left hand side which shows you your project. So this is obviously this is my LDL test repository here. If I add new files into this repository, so give it a name, Atom file, it's highlighted in green because Atom integrates well with the fact that this is a GitHub repository. So you can see down at the bottom, there's all sorts of features that are presented in the Atom interface here, which are due to this being a Git repository. So you've got the branches are there. You can fetch from, because it knows that it's got a remote repository, so you can fetch from that remote if you want. You can, if you log into GitHub, you can get information about this repository on GitHub because it knows it's on GitHub, and various other things besides. It also knows that we've made a change here, and it knows that that change is also in the repository itself. So the repository is highlighted as having been changed. If we make a change in one of these files, then that change is also highlighted there in the file as being different from what is committed to GitHub. And again, if we save that file, it's highlighted as having been changed. So Atom is integrating well with Git here, and is keeping us kind of up to date. It's telling us that we've got 2 changes here from our last commit. So we've got local changes in our repository that we perhaps want to reflect, and to do that we can make those changes. I think here in so here we've got an interface to Git within Atom, which allows us to make that commit here within Atom if we want to. So you can see that we've got README has been changed, Atom file is new. We can add our commit message here, and we can commit that change. Apparently we can't commit that change. That's interesting. I don't know why that's not working. Equally, if that isn't working for whatever reason, GitHub Desktop knows as well, and we can add, Okay, changes made in Atom, and we can commit that, and then we can push it. So if you set Atom, take the time to set Atom up correctly, which clearly I haven't done, then you can use that text editor as an interface to Git as well. And then just the final thing that I wanted to do, because again, obviously I've run on and on and on because that's me. I talked briefly last week about RStudio as an interface to Git. We can, if we set up a project, an RStudio project in our repository here, then the Git tab here should know when we make changes that those changes need to be reflected in Git. So what we should get then is, so here we've got two files which are not tracked by Git. So our git ignore and the R project file that we just created, because we just created an RStudio project in this directory. If we now create an R script, okay, and save it into our repository. Again, it appears here in the Git pane, and we can stage it, and then we can commit it. So the tick there will add it, and then we can commit that change, and it will pop up a little interface here, again showing us the commit that we're about to make, allowing us to add a commit message. Okay, and we can commit that file, and it's just telling you what it's doing here. So it's added that file, close that, close the commit, and our GitHub Desktop app should now know, oh, I've just pressed the button, sorry. The GitHub Desktop app now knows that it's a commit behind, and I've just pushed that. I pressed push by mistake. It's pushed that change up. It's added the git ignore and the R project files. They've been added by RStudio, and we could commit those as well if we wanted to. I've not done that yet, but you could do that. And we committed that and we pushed it. So again, we can pull up the repository on GitHub, refresh it, and see that all of our changes, we've pushed them all, and they're all reflected in this repository on GitHub. Okay, so I've gone through quite a lot of things in the last hour. One of the things that I want to do, or one of the things I am going to do, is take last week's video and this week's video and splice them together into one kind of Uber Git tutorial, which will probably be about 1 hour and 3/4 long, but try and clip out some of the not so professional bits and try my hand at video editing. So I'm going to do that. I'm going to kind of tidy up these two lessons into one big Uber lesson and publish that as a single video. But these two separate sessions will remain separate as well. Will remain in the playlist as well. But that's kind of my plan from between this week and next week. And then next week, as promised previously.